Welcome to our last day 7 topic, which is casework. So far we did our bowling pins and handshakes. We did the fundamental counting principle, which is helping us count outcomes. And now we're going to look at just some interesting examples, which we call casework. And it's really just casework because we're practicing problems that require organization in counting. So this all falls under our big category of today, which is just counting techniques, counting rules, all that stuff. So sometimes the most difficult part in counting is keeping organized. This is particularly true when working with diagrams. And you'll see these from time to time in practice competitions, pictures like this where you're supposed to figure out how many triangles of any size are in the picture. And the easiest way that I found to stay organized with these is I make categories. So I say small triangles. And when I say small triangles, I'm going to count this as one small triangle. And then I would count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then from there, I would go up a size. So then I would say, okay, that's the smallest triangle I can see in this picture. There is also, I would call that medium triangle. And this one is a little bit harder to see at first, but there's that one. If you do this generally, you want to look for the tips. So there's a second one, 2. I'll erase this just so it's easier. So that's 1, 2. With the tip 3. Right? So if you kind of think through the shortcut, each tip connects to one. So you could just say, okay, there's 1, 2, 3, 4, 5, 6 tips. So there are 6 medium triangles. The next size, I'll just maybe leave that medium highlight just for reference. That way you guys still have it. The next size I would say is your large triangles. And that would be 1 bigger than the medium, and it would be, going this way. Okay, so large triangles we have, that's 1. And remember, the tip trick worked for the medium one because it didn't extend the whole way, right? It stopped here. So you could use any of the tips to have those triangles. The tricky thing with this one is that these 3 are really the same large triangle, right? So that only counts once. So you can't use the tip trick for this one. And then we also have this one. So we've got 2 large triangles. That means our total triangles would be 12 plus 6 plus 2, which is 20 triangles. And like I said, really the only strategy with these problems is to be organized, go in an order, so start with the smallest triangles. There was the time saver trick here of using the tips for the yellow ones because they didn't extend all the way to the bottom. So keeping in mind those tricks, those will help you keep a faster pace in competitions. And then this one is kind of interesting. I gave you guys some practice squares here at the bottom, just in case you needed some extra space. I just, repasted that diagram. This one is a little bit more complex. How many squares can be formed using 4 dots in the unit grid as vertices? And the key to this problem is to find all the different possible sizes. So similar to before, we want to be organized. So what I might do is I might use the practice squares to, highlight each of the different sizes. That way you guys can see it a little bit more easily than using the same one diagram. So first I would start with the smallest squares I can see. That's these guys. So doing that, there's 1, 2, 3, right? 3, 6, it looks like 9 as I go all the way around. So that's the smallest thing that I can possibly find. Let's try and do the next size. So the next size would be bigger, right? We would have this one. Because remember, they did say squares, so we can't do rectangles. So that's 1. But I could also, I'm going to kind of think about focal corners. So there's 4 corners. So you could jump to 4 as your shortcut. because notice you do need 3 lines. So you will always be using one of the final lines, which means you'll be using one of the corners, because it's 3 on the bottom, so you can't do anything just in the middle. So you don't have to worry about anything that is not touching a corner that's somehow in the middle of the diagram. So that means there's going to be 4. That's the 1, here's the 2, 3, 4. And I'm just going to leave the 1 square there for reference. So I'll call that medium. There's going to be 4, and your trick to see that is the corners. So anytime you've got a trick like that, similar to up in this one, where we used the points, right, your vertices, you want to keep that in mind with anything that can help speed your timing. So that's a medium. Let's look for a large one. Now we had a 2 by 2 here. We had 3 vertices by 3 vertices. So the next one would be 4 and 4 vertices. So that one is large. There's only going to be 1 of those. Now the trick with this one is there's actually more complex figures that we can make. And the trick with this diagram is you can do kind of diagonal ones or tilted. So I'm going to call the first one the small diagonal. And what that's going to look like is, I'll draw it down here maybe. It's going to look like from this vertex I could go here, here, and here. So that's what the small diagonal is going to look like. So notice you have to have that span of 3 dots across in order to make the picture. So there's 1 there. Looks like we would have 2. We would have 3. And we would have 4. Now looking around, if I was to try and use the corners, that wouldn't be possible. So I would say that small diagonals have 4 possibilities. And you'll get faster with counting these as you get extra practice as well. So keep that in mind. Okay. From here, there's the possibility of, can we draw diagonals that are even bigger? So I'll call that maybe a large diagonal. Right? You just want to make sure you've tested all the possibilities. So if I was to try and do a larger diagonal, this one's a little harder to see, but if you go from here, here, like that, you can make that one larger diagonal. And then there's also a second one. I'm just going to use a different color for this. So you can also draw this. And this one's kind of harder to see, I would say. And those are the only possibilities because of the dimensions of this. Notice you have to go like over 1 up 2 in order to plot that next point. And there's not really another way to do that in this diagram. So we would say that the large diagonals, there are 2. And your total, if you add all of those up, you should have 20 squares. Okay, so that's the last example problem, I believe. The other practice problems are similar to these in that you need to be thinking through the different sizes. The first one, the green practice, is pretty straightforward. It's not that complex. And then by the time you get to number 2, it does get really, really complex. This one last year during the summer, my students and I tried doing this all together where, you know, we all put our heads together and we were trying to think through the best way to count them. And this one is pretty complex. So this one might be a good one to work through in groups and try and see as a class how we can best categorize it and what the most efficient way to count the possibilities is. Okay, so that is it for casework. You guys are done for the evening. I'm excited to work through these problems with you tomorrow and hear all of your different ideas and ways of better counting. Have a good night.